But the point of this talk is, many years ago when I was getting into Unity, I kind of found, eventually I did find a blog post that kind of did what I wanted to, but as someone who has used game engine before, or has used programming before, that kind of thing, I found a lot of kind of beginner tutorials, both lacking and overly verbose in some ways. So this is an attempt to give in half an hour. It won't be a complete, obviously, encyclopedic knowledge dump, but the idea is to give people who've touched on the game engine before, maybe use Unity, maybe use some other game libraries before, just enough threads for you to pull on, enough bits of information for you to kind of go away and find the bits that make sense for you or for the projects you want to work on. So it's not that you have to be a programming expert or anything close to that, it's just that you have to work with games technology of some variety in the past, so we've got some experience with some of the words that I'm going to be using. If not, shout to me, and we'll attempt to define them in a useful way. So yes, that's really the kind of who I'm targeting with this. And it's half an hour, so really I'm not going to be able to go into super detail on any specific topic. It's more about giving you threats and giving you some ideas about future things you might already just look at. I'm not live coding. Although I might be doing some fiddling around just to give you some idea of the thing. So, practice, and we will see if that succeeds in not breaking on you. We will see. Yeah, for instance, that's the thing I was saying. Before, apologize about the audio, this is coming through right.
Yep.
Before I go any further, if you do have programming experience, you no doubt have developed some opinions about programming languages. And quite a common one that I see is people saying, why would I touch Godot? I wrote a custom scripting language, which is an insane decision, I do agree. And it also looks like Python, which is distasteful to some people. Basically, what I would say about all of that stuff is please do, if you're beginning your journey with Godot, I would probably just start using VBScript anyway. Hold your nose if it is distasteful to use in some way. Purely because it's so well integrated with the engine, and if you use the built-in IDE, it'll give you, nice auto completion suggestions. The documentation is already built in there and stuff. I say this as the sort of person, to be clear, I run Emacs, and I use all my development in Emacs, right? So I am an absolute arsehole of an idiot of a person to take a recommendation from this one. And I'm saying use the built-in IDE. It's shiny and graphical, right? So I don't know if that helps at all, but anyway, please use it to begin with. I think it's well worth doing. Even if you're planning to move to C# afterwards, you're basically talking about translation between snake case and camel case in a lot of cases. So if you've developed knowledge about the APIs, about how things are put together, it's going to translate directly to C# if that's what you want to go afterwards. And of course, it's well worth pointing out that the way Godot works is we could extend it with something from C# if your case. For example, I've done some work with Zig, which is not recommended for production, but it was quite a lot of fun. So please just bear in mind, I'm going to be showing all of the stuff I'm going to be showing is using VBScript. So just bear that in mind. Also, if you like Python, if you like me, you come from a background writing Python, you'll find the comparison rather annoying because, of course, it's not really like Python and it's missing a bunch of stuff. So no one's happy and everyone's learning. But let's move on. I did say, as well as using VBScript, it's worth using the built-in IDE just because it gives you a lot of stuff. That was the intro. Done faster, which is good. That was the easy bit. So, the main concept, the only main concept that you need to take away from this talk is nodes. Nodes are game objects, and that is as useful as it is boring as definition. You all probably have your own idea of what game object is. If you come from, I don't know, what's the Java monkey engine, you've got a very OOP idea of what game object is. If you come from Unity, you've got this twisted idea of what an entity component system is. But nodes are what those are, and it's a useless circular definition. So what we're going to do instead is we're going to jump straight in and do a little bit of fiddling about. So if we are looking at a 2D scene, we just arrange it. Is this visible? Yes. Good. So part one, 2D scene tool has to begin. So we're going to create a 2D scene. and I can just grab some sprites I've got prepared here, and I can start dragging them around. Let's see if we can scan anything here. This is all K, by the way, in case you recognize the assets. They can do some other things, but that would be more. So I didn't.
This is like coding.
Yeah, well, it's like dragging and dropping, isn't it? All good stuff. So I'm throwing some stuff around here, and again, the idea is, hey, hopefully most people in this room are familiar with the idea of a game engine, and even if you've never seen Godot before, you can maybe kind of get a picture of what I'm doing. I've thrown some scripts in. We've got this scene here with them, and we can already see basically everything I've created here is a node. But they're not just visual. Everything that you're going to be creating in Godot is constructed from these trees of nodes like this. And if you're familiar with the concept of a scene tree, it is basically that. But what we've got here are all visual nodes, and we can already see that there's, as well as stuff you'd expect from them, these are some sprites on the screen, fine. The structure of the tree has some meaning depending on what the nodes are. That's a useless statement. I would argue that most of the time, the relationship between the items in the tree is quite intuitive, it's what you expect of it. So for example, the ordering of these things matters. If I drag the background over here, you'll see the ordering is the order that things are getting written in by default, right? So essentially that's quite an obvious thing to expect. But anyway, so these nodes, they're just objects in a classical object-oriented sense, and we compose them into these trees like this, and that's what's gets rendered and activated and run by the engine. So let me first my notes. Let's check my time. Good. Yeah, so what I've just done is some live dragging and dropping. It's worth mentioning, for those of you coming from a more pure programming engine background, we could recreate a scene very similar to this, just purely in code. So if I take a look at this, nothing on my sleeves, run this scene, you'll see that there are in fact some assets in here, well placed. If I take a look at the code that I touched on here, so this is kind of what you might expect if you were just writing without a visual editor. So I'm going to create a new sprite, I'm going to load up some texture for the sprite for what it's showing, I'm going to assign the texture to the sprite, this other stuff here. The only thing I will add just significantly is this add child concept, right? So nodes don't have to be visual, they don't have to be 2D, they don't have to be 3D, but the core concept of nodes is that they build this tree together, and so they have this method, add child, other associated methods for building out these tree structures together. To maybe demonstrate that, I think it kind of makes it a bit more obvious. So I'm just going to quickly dip into the kind of live debugging aspects of Godot. So now I'm running this game over here, and you can see on the left here, I've got this remote view, and I can see this tree structure, which is what I've created in code, and it matches basically what I've done in the visual scene over here. So I'll stop beating you around with this particular hammer for now, but I just want to kind of point out that everything you're doing in the visual editor you could equally accomplish in code in the same way like that. Take a deep breath and move on to the next bit. Yes, so the other thing, or I guess to kind of carry along on the same thing, if we just close our live running one. If we go back to this unsaved scene that we created here, just by dragging some stuff around here. If I wanted to create multiple of this enemy, let's just quickly fix this. So this texture actually has 3 sprites in it. This is the nature of the quickfire thing. There's little tidbits here that you might find useful. So by saying it's an animation with 3 H frames, we can put it down to that one frame. And you might imagine how we might be able to animate those frames later. Anyway, so if I wanted to make multiple enemies on the screen, I can dual wield my microphone and mouse. I can press Control the duplicate things as you might expect, and I can drag them around. But what we've created there are just duplicate sprites, right? And so what might be a nicer thing to do is I say, okay, this enemy object, I'm actually going to want multiple of those ones. So I can say that there's a separate scene. Let's just say there's this matter, this one. I'm sure I won't break anything. And now this is a separate scene. At the moment it's just a sprite, obviously, but as we go along, we might want to add scripts and more nodes to that. And we've created a separate reusable scene. And scenes are just scenes. Scenes are just nodes. Nodes are just trees. It's all trees and nodes and scenes all the way down. So that's the main concept that I'm trying to get across here. Compose nodes into these scenes, and then you have sub-scenes, which are your little composable components that you want to build in here. So I've got this reusable enemy here. Nice. Cool. Well, moving on from that, I'm just going to quickly talk about resources. Resources are the other half of the things that you should know about Godot, and they are super boring, so I'm not spending much time on them. They are useful to know about, and you should know about them. I created those enemies. I won't go back to them, we'll see more of them in a second. Multiple enemies, different objects, do different things in your game, just as you'd expect. But they're using the same texture. So again, if you're used to maybe writing just using library code or that kind of stuff, you might think, oh well, is that loading the same texture twice? Is it doing something understood? The good news is it's not, because the textures being used by those sprites are not resources. If we just quickly take a look, we can kind of demonstrate that maybe. So the sprite is the node, is the object that we've created here. And we can see here under the texture is material. Well, it doesn't matter. I forget what I was going to say. But no, actually, the in code is probably.
It's right up at the top of the sprite.
You're right.
You clicked on a scene, not a sprite.
Yeah, texture, there you go. So yes, the texture is the resource right at the top there. And basically, if you refer to the same texture multiple times, by default, Godot is going to load it in once and then give you the same reference to the same texture. In this example, we're talking about the texture. Most of the time, that makes sense. And is what you want. Nearly always is what you want, in fact. The only reason it's really worth bringing up here is because sometimes it isn't what you want, and if we've got time at the end, I can maybe show an example of this. Resources like this is a sprite which I've created outside the game, which obviously, but resources can also be things like UI themes. Basically, any data object that is serialized to disk and loaded up again can be represented by a resource. And so you can basically have a scenario where you create a node, you duplicate it, and then it has a reference to the same underlying resource, which then if it's the theme for the UI, for example, you edit that UI theme and it affects both the nodes, which again, generally is mostly what you want, but sometimes when you're in the middle of editing stuff, it can be surprising. So we'll show an example of that if we want to, but I felt obliged to talk about resources because they are useful and as experienced somewhat, potentially getting people, you should know about them, but they are very boring. So I will leave you with one last tidbit, which is that in the game I'm currently working on, I do make use of kind of the functionality resources extensively, specifically when it comes to user preferences, right? Because it's something that's saved to disk, you want to load it when the game is, maybe you reset the game for volume and all that kind of stuff. But then also, resources are just objects again, so I can script them like I would anything else. I can use that resource to then basically inform parts of the running game when the user changes something. So if they change the volume, there are various aspects I need to know about that, or certain visual aspects I need to change. Resources are a useful way to do that. I'm just going to talk about them now because it's not very visual and fairly boring. So we're going to go on with the show. Just do one more time check. So that's great. So, everything we've done so far is pretty boring, right? Like, we've put some stuff on screen, we've talked about nodes, it's all pretty theoretical and not very interesting. So if we switch to part 2, you'll see I've prepared essentially the next version of this. So, nodes are game objects. Game objects you compose in a tree. That's all very well and good, but what's the point about game objects? The other thing you probably know about game objects is that they have a common set of methods. Doesn't matter what engine you're using, they're all named a different thing to what they call in Godot. But you're going to work it out anyway. So by adding your node to the tree, what do you get for free? Well, you get a bunch of nodes, a bunch of methods that are going to be called at the appropriate time. So if you've worked with Godot before, you've probably got a method called update, which is run on a tick, and it's given a delta time. They call it process instead. It's the same thing, it doesn't matter. Physics process, it's the physics update tick. You've seen it before. Ready is called when it gets into the tree in the first place. Input is called when you get some input stuff. The point is, you put your nodes in a tree, and Godot will call these things for you at the appropriate time for you. And I've put that child in here, but I've already talked about that, and it's boring, so we won't talk about it anymore. Better to show some stuff, I guess. So here we are in part 2, and what have we got here? Well, we have the same group of enemies. If we look at them, we have them, just the same things we've had before. But we've got a script that we can add to our player. And again, I'm sort of skipping over like granular stuff here because hopefully people are relatively comfortable with the idea that we've got an object and we want to write some code that does the stuff with that object. So player is a sprite, and Godot is determinately disoriented to a default. So if we take a look at this script here, our script extends Sprite 2, so we're inheriting from our Sprite 2D class, and therefore getting access to all the methods that you could do with a Sprite 2D. We don't cover any of those because we're just moving stuff around. So we've got our process, which we covered is our update statement, and we've got our delta being passed in, and we're doing some very simple calculations to see if the user's pressing move right, move left, move down, move up, and we're using that to build a 2D vector to express what movement the player is trying to do, and then we're timesing it by some speed. So yeah, I think hopefully that's relatively easy to kind of see what's going on. As a second class that we can take a little look at here as well. So I'm very conscious of this not being a you're coming from Unity talk, but I will briefly say, obviously if you're used to the way that Unity works, again, it's objects with components attached to it, that kind of stuff. This is, again, sort of classical OOP. I'm just overriding and extending the class of the object that I want to script. But of course, nothing prevents you from using the tree structure to do separate components and separate amount like that. So this is kind of an example of that. If we look at this XMover script here, all that does, it extends node, which is like a super low class in the hierarchy, and then it has an update process method that's going to get the thing it's attached to, get its parent object in the tree, and it's going to affect its position. So you can attach that to things, and it acts like, a component. So, minor note, I've given this a class name here, XMover, and the nice thing about that is that then it'll appear as like a built-in thing. So I can go to enemies here, I can say control enemies, add something, I can start typing mover. You can see this class here is available for me to just add on the object. And yeah, if we just take a scene, see what we've been messing about with. So we've got our XMover thing in play, doing the whole amount of the whole section of Ghost to the left, and I've got my keyboard input set up so that I can move my player around. So I actually skipped over something there which I was intending to make a significant point about, so let's attempt to backtrack. I talked about how the tree is significant and the structure is used to define things. Again, the ordering in terms of how things are rendered, maybe that makes sense. Also, you've got this kind of parent-child relationship, right? So I've got this group of enemies, and I put them all under this node here. And if I wanted to move, if I move that parent thing, it moves all of the child objects there. So again, this feels like, well, great. He's pointed out that you move the things around. Yeah, I know, it's super obvious. That's the kind of the point. Like, they're 2D sprites, and they have a position, and therefore, if you parent them to other things, their position is relative to that thing, which to me at least kind of makes sense intuitively. But these are 2D visible things, and other things don't necessarily have position or other stuff like that. But anyway, hopefully that gives you a taste of these are nodes, we can script them, we can add other nodes as children of them and use them as a way to sort of do components in that way. Yes, so let's carry on talking a little bit about the debugging, live editing, integration with an editor. It's a neat concept that you can definitely wrap your head around. Let's go, press one on the screen. One thing I will point out, well, just so you mentioned, do not have any good at all. One thing it does do, which I think is quite nice, is the way the Windows is embedded when you run it. And Godot does this thing, which is kind of cool. But anyway, so we've already seen the remote tree here. You might say that our game, our player movement is a little bit boring, right? It's pretty slow, and I'm going to have a real difficulty moving every one of these things here. So I can go to that remote thing here. I can see our player. We can see our player speed and variable that we've defined. And we can edit that. So it's 250, and all of a sudden we've got a much zippier character. So if you were wondering, ooh, how can I introspect and poke around my game while I'm running? This is how you do it. So built in kind of live view of the tree, that gives you a bit of awareness of. However, having that player speed built in, be tucked away so that you can't, so you can only do it through the live thing, maybe isn't the exact vibe we were going for. And so if we skip to, it's in part 3. So if we move on to part 3, we've done a couple of things. Let's just say it's do it live. So go back to part 2. We had our player speed, which we were able to edit. And yeah, it's a game engine, you're working with other people, maybe they're less technical, and you don't want them to have to make code. Okay, Godot has this export idea, which is basically saying this variable is something which should be edited through the UI. Right? So I've said this is export there. And if we skip back to our scene here, we'll see that the player speed is now being exposed as a variable heading through the and you give this to technical people, make it easy. There's loads of stuff in here about the different types of values that you might want to expose here, and you can put restrictions on that. You can ask people to, it might be a link on a node, that sort of stuff. But we're already running past time, I think, so we're probably going to skip a little bit past that. But export bars, they're an important thing in terms of exposing parts of your script to the UI. But collision, we skipped ahead, and so we need to see it. So here's our collision. I've gone ahead a little bit. We've got a different enemy model now. If we've opened this up, you can see it's. So this is what I was saying before, right? We've got a separate scene, but now all of a sudden the separate scene has more structure to it. So we've got an area 2D, we've got a sprite, which is what we're seeing over here, and we've got a collision shape. And this is another example of how the tree structure works. So for collision objects, you have some type of collision object. This is an area 2D, which doesn't do anything super exciting, but it's useful for detecting collisions. There are things like kinematic objects, if you want to do balls bouncing around and that kind of stuff. But if you're going to have a collision object, you want some definition of what the collision area is. And Godot uses the tree structure again. So you have your actual collision object, and this is the shape that defines, which you can kind of see in this colored thing here, which just defines what the actual shape of your object is. And if we toggle on back to here, so our enemies are collision stuff, our player is not. Given time, I'm going to do this live, I'm just going to skip to part 4, and you can imagine I did this in a very impressive, alluring way for you. But what we've done here instead is we've defined our player again to be to have some structure to it. So we've got an area, we've got a sprite, and we've got the collision shape as well. So I've also updated the scripts accordingly, and again I'm going to go through it super fast. The idea being this gives you something to pull on. But it introduces a different concept. So our enemy has a script. It's an area, which is a collision thing, and we are introducing the idea of signals. Signals are just events. Ignore the word signals are just events. You've seen them before. Very languages, they're fine. This is an area, so one of the events that it might happen is something comes into this area. It's a collision. And when that happens, we would like you to call this function here, area entered. And if the thing that has collided with us has a method on it called die, then we're going to call the die on it. Seeing increasingly blank faces, so I am sorry about the speed at which we're going through this at this point now. But essentially, we're taking advantage of the tree, and we're seeing an example of events, and basically one way to handle it. If we take the player script, we have kept some of the same logic before. We've got our input manager here, it's getting left and right and up and down. Got a new action here, just saying if we press the fire button, then we want to call our find button. And again, this is, maybe I'm beating you over the head with it, I don't know. But again, this is reinforcing the idea that everything is just a tree of nodes. So when we want our player characters to fire a bullet, all we're going to do is we're going to take our bullet, which is just another scene, and we're going to create a new instance of it, add it as a child to our player node, and on its own, not super interesting, the bullet scene itself has some logic. So if we just take a quick look at what we're dealing with now, so we've got our position shapes on. So we've got these things we can collide with, and if we collide, we get some game over. And alternatively, if I press space, you can see these wonderful bullets. There we go. You can see our points going up. So this is GTA, right? But yeah. This is an attempt to put it all together to give you three steps. So I will speed up. This is the final scene, and I kind of wanted to give you an example of a script that isn't really long, but it still kind of pulls together a bunch of these concepts, right? So you've got nodes in a tree. Maybe you can imagine how you would go to look up the API for what a collision object does, and you can see the methods. But if you're writing a game, the kind of question that you run into basically 10 minutes after you've done that is, okay, I've got all these things floating around, how do I make something interesting happen when they interact with each other? How do I have a game loop that does stuff when you die, or whatever? And so this script here, which we've just seen the results of, this is showing how you go about getting, or some of the ways you might go around getting away reference to other nodes. So we've seen the scene structure. This main script is right on the top of our scene, so it's right on the top here. And one of the ways that you'll see time and time again in Godot is this $ syntax, which is basically a shorthand you can see in comments. So for player equals $player. You could do this in a more roundabout way by saying var player, and then in your ready function, we get look for a player in the tree, get node player, which is just a look down this structure of player here. That's obviously a bit tedious. You have this ready var $print syntax, which allows you to do that. You'll see that all the time. The obvious pros and cons of that are you need to know where your thing is in the structure that you're looking for. And if you move it, you might have a mess. But it makes a lot of sense for things that live together. If you've got a player object that's a bunch of different nodes, it kind of makes sense to use bots because you need them all together anyway. You're expecting to be. Take that with a pinch of salt. But anyway, that's my rough rule of thumb for that. So we have some other ways of getting access to nodes. I'm already at time for them. You can put nodes in a group. That's a nice way of finding things. If so for example, you've got enemies all the way down here, you want to move them around in this structure, you don't want to rely on the fact that you have a node called enemies just below the root containing them all. So you can put them all in a group called enemies, and that gives you just a random way, but a general way to get all of the nodes in a particular group, wherever they are. And last of all, I've included an example of find child, which is a slightly more loose version of get node will just look down the tree for a particular pattern that exists. So again, if you've got a specific name or a particular object that you know will be there, you know where it is, we want to be flexible with it. Find chart is a useful thing for that. We skim through so we can see. You get it. We'll talk about some other stuff. Yeah, so here's the way sort of the nodes. Get node, you've got assign, find child, put them in a group. Globals, and then they called them something else because they realized they were getting a bunch of stick from people with opinions about globals. But they exist, they're fine, don't worry about it, it's a game. Signals are events, don't worry about those either. So, we're at the end, and I want to point out some other places you can go. This is called Kids Can Code. Don't be put off by it because it contains some of the most concise examples of nice player character controllers for different things, like an arcade aeroplane and a hovercraft and stuff. And it's a kit designed for kids, and there's way more succinct than this talk probably. So go for that. Godot shaders. I wish more people knew about this because it makes Godot look like a real engine because it will look really cool. It is a real engine, but you know what I mean. Like, come on. Anyway, also docs. Like I've encountered so many people who don't bother looking at documentation, and the reason is because documentation is crap. But for Godot, it's kind of alright, so it's probably worth looking at it. Specifically, the list and the description of all the classes. This is narrow classing now, but if you're the sort of person who would buy a game and then read the manual to it on the bus on the way home because you have nothing else to do, read it on it because they're the same kind of vibe, and it will make you think of cool things you can do with it. I haven't touched anywhere near all the things available. These are some specific things I would potentially go look at next if you're interested, just because they're the sort of thing you might want to use in a game, and they exist and they're useful. One thing I didn't touch here, I was going to, is the animation system, which I think is very smart, and you should definitely look at that next. This is me. I'm just going to put the slide here later. So, fini. I don't know if we're doing time for questions now or no.
Yeah, if there's a couple, then we'll do
2 questions.
Yeah.
Cool. Any questions? Yes.
You said the game I'm working on.
Yes.
Is that a game that we can see later?
You can see the game jam game that was based on. Yes. Thank you. This is very good promotion. I didn't ask for this. No, I'm working on a game called Residence on the Stars, which is about exploring a billionaire's attempt to escape ecological catastrophe. And then it's like Thief on a ship. But imagine if like Elon Musk buggers off, and then you have to like crawl through his ship full of idiots. And yeah, there's a joke version of that available on which Thief in storage. Thank you. Good question. One more question, I guess. An actual question. Yeah.
Can you interact with like APIs with GD scripts? Like, say I wanted to use like OpenAI or something, have like an AI generated character or something. Could you do that?
That is a great question. You absolutely can. So GD scripts, I would say overall they made fairly sensible decisions in that it's focused on being a game scripting engine, language, I should say. There is, however, a client for making web requests, which would basically give you everything you needed. Again, going back to the slide that refers to Python, if you use Python, you're going to have a terrible time, because it's like 5 times longer, and you know, it's like before requests was written for Python. And, but it's fun. It's totally, you totally should do all of these things, yeah. I think overly you definitely could do all of those things, yeah. Cool.
Sweet. So, like 5 minutes, and then get yourself a drink, and then we'll have another talk.
Yay.
Thanks very much.
Just out of interest, has anyone in the room, just quick show of hands, has anyone been using it since version 3? Okay, yeah. We got some real people here. Lovely. Okay. Anyone from before that, version 2?
I tried to, but it put me off.
Yeah. Was it like, anyone from Argentina? No. All right, great. Yeah, I've got a couple of games out. Feral Flowers, if you know me, I've definitely badgered you about that. Embervania, how to use your phone. These are things that I have like definitely badgered people with at social. So sorry if I just like run up to you with my phone and be like, play test this. Go. Yeah, that's happened loads of times. So yeah, I don't know. So yeah, lots of work in progress stuff, to be honest. Most of my life is work in progress. This is more like an hour now because I've been listening to our previous speaker. But yeah, this has just been made, and I only just found out a way of kind of making it work properly. So apologies if it doesn't really fit together, but yeah, we will see. So yeah, design patterns. What are they? So in the past, when I've heard these words, my skin kind of crawls, but they are useful. They are useful. And so the thing is, it makes me think of like agile managers, like product owners and things like that, and people who sleep with a copy of clean code by their bedside table. But I'm here to tell you today that it's not all about that, actually. And what I'm hoping to get across today mainly is that as you learn Godot, you'll probably find yourself like doing these things anyway. But it's just that having a label for them makes them, it just helps you design more quickly. So yeah. So what is a design pattern? Oh my word! Right, so I'm just going to read this out loud. In software engineering, a software design pattern or design pattern is a general reusable solution to a commonly occurring problem in many contexts in software design. A design pattern is not a rigid structure to be transplanted directly into source code. Rather, it is a descriptional template for solving a particular style of problem that can be deployed in many different situations. So yeah, pretty meaty, but yeah, let's break this down a little bit. So it's a general reusable solution to common problems. So you can kind of think of these things as a bit like tools in a toolbox. It's not a rigid structure. It's more like a description or a template or a best practice in making software. And I know that this mentions source code, but if you've used Godot, you know that like you'll be spending a fair bit of time in the visual editor instead, dealing with nodes, and it applies to that too. So it's not just code; it's design as a whole. So this is basically a talk full of tips and tricks. Okay, so I was going to do another show of hands quickly, actually. How many people here would say that they're like an ace at design patterns? Like, how many people think that I'm going to be telling them stuff they already know, basically? Nils, of course. Anyone else? Okay. And how many of you are completely lost? What about that? Okay. Cool. All right. Well, that's that's I was expecting. So yeah. All right. Godot talk featuring Clippy. Let's do it. So I'm mainly going to be talking about things to do with GD script. So if you're using C# or something else, I'm sorry, but yeah, not today. So yeah, let's start with what's called the state pattern. You might also hear this referred to as a finite state machine, which makes it sound very sort of mathsy, but it can actually be thought of like way more simply than that. So what you're looking at here is Feral Flowers player physics process function. As you can see, it's pretty bloody long. It's very big, it's very complicated, and the reason it's so big is because the player has lots of different states of being that we need to account for. So there's standing, there's running, there's jumping, there's falling, there's knockback. The code needs to account for all of these things. So the stipulations for every single one of these things is there in that function, which is just kind of insane, really. It's just muddled up, it's just a piece of spaghetti, really. It's really easy to trip yourself up because you've got all of these different lines of code going on at all of these different times. It's difficult to kind of figure out where things are happening. So how can we fix this? We can use the state pattern for this, basically. sake. Okay. What the idea is that you take each one of these different states that the player is in, and you can. So in this example, we're just having a separate GD script file for each one. Sorry, I have lost my way in my notes quickly. Where are we? So yeah, that means that you can effectively condense your physics process function down to something like this. As you can see, I've been really fancy here, and I've used a dictionary to map, literally, the different states to the function that I need to call. And yeah, this is, I mean, basically, this pattern falls under the category of things I figured out were a good idea by myself eventually, and then found there was a name for later. And you're going to be seeing like a lot of that in this slideshow lately. So yeah, we might get into finite state machines and this so-called strategy pattern later on in the Q&A if anyone wants to hear about it. But unless you do, I'm not going to talk about it basically. So yeah, prototype pattern. This one's really simple. So when you've got something in your scene that you need to make several copies of, once your game has started running, that is, because obviously you can just duplicate stuff in the editor really easily. There are a couple of ways of doing this. So let's say that you've got something that you want to copy, right? Yeah. Then basically you can just keep this object here in your scene out of sight of everything else, right? Kind of getting the analogy here. Any of the people in the room? Yeah. All right. Fantastic. So yeah, either you want to make it invisible or just put it just out of view of the player. So it's just like outside of the camera or the viewport or whatever. And then in your code, you can just use the duplicate method to get a bunch more. And you can customize those copies as much as you'd like. The other option is that if for whatever reason, I know we talked about this briefly in the previous talk as well, you can also use scene instancing. I'm not going to get into that here because I could do an entire presentation on scene instancing. But yeah, this is again, it's one of those things I've done before, and only just realised I had a name while I was making this presentation. So yeah, apparently, if you do this really simple thing, that makes you some kind of pro Godot coder. So yeah, that's nice. All right, next up we have the flyweight pattern. So this one is really simple, and it's actually quite difficult not to use it in Godot because the flyweight pattern, which is apparently has been called since the 90s, is actually just using resources, which you can't not do if you're making basically any game in Godot. So it has a weird name, but I was going to ask whether people know what a resource is, but hopefully after the last talk we do have a vague idea. So essentially, where are we now? Sorry, I keep losing my way on my notes. So, has anyone here tried duplicating a collision shape in Godot, and then this happens? Does this look familiar to anybody?
Thank you for demonstrating.
Yeah.
I think I was struggling.
Yeah. So what can happen is that if when you resize one of them, you resize all of them. And the reason for this is because rather than changing the scale, which is in here, you are changing the shape. And that shape is, if you just like take one of these nodes and then you duplicate it, they all share the same shape. It doesn't bother to give them a unique shape. So there is a good reason for this. It actually, it's really good for optimization. It makes the engine less power hungry. It makes it, you're not going to drop as many frames. It's going to use less memory if these all share a shape. So if you happen to have lots of collision objects that do have the same shape, then by all means, like, this is fine. But yeah, the downside is that you have to explicitly say that you want to make each shape unique if you do indeed want that to be the case. I don't know, like, I'm sure that if any of you have used Godot here, you've probably clicked on this button loads of times, I would imagine. Because yeah, you're going to need to do just that. So next up, basically, sorry, I've made like a spelling mistake here. Really annoying me. You can take basically any one of these resources, like for example the rectangle shape here, or like I don't know, even a variation on a font. Any resource, you can actually save it as a file, which is really good because that means that whenever you edit that file, all of the nodes that use that resource will be automatically updated. So you can use that for things like, I don't know, like automatically updating the font throughout your entire game. If you're a maniac, you can choose to do that and you can deal with the fallout. You can also make your own resources. Like you can inherit from the resource class if you really want to, but I'm not going to get into that here. I've done it before, and it's quite useful because you could just use them as general data containers. But yeah, we're gonna push on now. So the observer pattern. So this is the good stuff. I'm sure, like if you've taken any tutorial on Godot or watched any, or like read the docs especially, you've definitely heard of this. It deserves an entire talk, to be honest, but again, this talk is about 5,000 things. So we're just going to say that signals are the bomb, and we're going to use an example to explain why. So let's say you're creating a gigantic humanoid weapon, for your game, right? Now, normally, you're going to want the player to get inside this thing to use it, okay? But the entry sequence is a bit complicated. There's a cutscene, it takes time, it's dependent on the player's stats, yada, yada. So during testing, you don't want to have to go to the hassle of assuming that there's a player in there. It's a pretty fatal flaw of this particular gigantic humanoid weapon, if you ask me. Or there might be something else entirely in there you want to put in. Like, it doesn't even play by the rules, like, who knows? So the point is that with signals, you can test each part of your game independently. If you have one game object calling functions on another game object, and they're not in the same scene at the same time for whatever reason, you're just going to get a crash. And signals completely alleviate the need for that. So with signals, rather than calling functions, it's more like sending a message out like into the void to anyone who happens to want to listen. It's just a really useful way of designing things, to be honest. You can test. The idea is that you can test the gigantic humanoid weapon on its own, and you're not going to need to second guess what is going to happen when you do that. Signals. Use signals. Signals are great. Use them. Next up, composition pattern, which is just nodes. So this is probably going to be a pretty quick one. So basically, I don't know, like arguably this is just kind of how the scene tree in Godot works. That's it. So I'm basically not going to say any more here, other than that there's a conflicting school of thought, which is something called the entity component system. Now, I'm going to get another show of hands. Is anyone here an actual entity component system fan? Any ECS fanboys, fangirls, fan MBs in the place? No. Oh, okay. All right. Cool. This is a good crowd. So basically, Juan, this is the guy who basically made Godot, and he's not a massive fan of it, to be honest. He did an entire blog post, which I will mention later, actually. But yeah, we're not, generally speaking, Godot is just not designed for this. And though there are plugins that make it work, it's just like, if you happen to have heard of it, if you want to implement it in Godot, I would generally not recommend it. And again, this is deserving of its own talk. Moving on. This is the second last pattern we're going to talk about today. This is another big one, not only for Godot, but definitely in game development in general. So does anyone, I'm going to do more crowd participation. How do we do singletons in Godot? Anyone shout out?
Auto-load.
Yes, auto-load, exactly. So we literally just use this, which is in your project settings. So it's pretty damn simple. And all you need to do is choose a node, and either that will be a scene or just a script by itself. And once you've added it here, that node will be omnipresent for the entire runtime of your game, unless you delete it for some stupid reason. But yeah, it's always there, it's always watching, and there are lots of good reasons you might want this. Anything that you want to preserve as you move between the different scenes of your game, it's very useful to just have them in a place where we can access them. There are things that you might want to save, player stats, save data. The number of dads have kissed in the case of Dream Daddy. if you think about what we'd have to do if we didn't have the dad kiss tracker available, you'd have to effectively pass the number of dads kissed into every single scene of your game to make sure that that scene knew how many dads you kissed, and therefore how to react, how to make the characters, the dads, change their dialogue. So yeah, really useful. It'll get messy fast. Now, there is an exception here, which involves static variables. This is so annoying. Oh. All right, hold on. We might we might be able to fix this.
How much do you have left?
Sorry.
How much do you have left?
How much do I have left of what? They're like 2 slides, but they're quite important. So yeah, we're going to try this. All right. Has anyone here got an Amiga Workbench floppy by any chance? Anyone?
I do.
Who's that? Ash! Come on down, man. Come on.
Yeah, I got an Amiga at home.
I can't believe this. Imagine that. Ash just randomly having an Amiga at home and bringing his Workbench floppy.
I'm a retro guy, you know that.
Fantastic. Yeah, there we go.
Is it the right version?
Yeah. Well, I presume so. It doesn't have a version on it, but yeah, there we go. He's okay, folks.
Hey.
Hey. All right, let me just put this into the floppy drive that's on my laptop. All right. Hold on a sec. This might take a moment. I don't really know what happens at this point, to be honest. We good? Do you have to wait a bit here? Oh, okay, there we go. Oh, awesome. All right, great. Yeah. Okay, so, basically, the last pattern I wanted to tell you about is to make sure that you basically always save your work. This is not that. This is just something. This is like the most important thing that I could do to tell you about game development. If you use Git, please use Git. Godot is very, very good with Git. But even if you don't, just like copy the folder and put it somewhere else every now and then, because yeah, you'll you'll thank your past self when you do, even if it does give you a neck beard. So yeah, remember to save. And that's it. Thank you very much. By the way, in case you hadn't realised, this was actually made in Godot, it wasn't made in Google Slides. Okay, so I don't know where we're at with time, but does anyone have any questions, answers, anything like that? Anyone? No? Dust? No? Okay.
I have a question.
Go on.
Was the text put in by you?
With the what, sorry?
The text. They were you.
Oh, I can't tell you that. So what I'm going to do is I'm going to tell you about the bibliography. So 2 important things I would recommend that you read here. So GD Quest, I know that like everyone talks about this, but yeah, it's a really good resource, and their documentation on design patterns is actually like surprisingly meaty. I was expecting them to be like kind of dumbing them down even more than I was here, but I learned like a good bit of the names that I had like for the stuff on the slide from there. So yeah, there you go. Also, if anyone is interested in this, I know it's a little bit of Godot archaeology, but yeah, if you Google Godot log ECS, you will get this. And basically, it's him explaining why we don't use entity component systems in Godot. And yeah, I think that's about it. Your drinks?
Yeah.
Yeah. My drinks? Yeah.
Effect. It's well easy. So just go up here and put into this little search bar particles. There's 2 kinds, there's CPU particles and GPU particles. This was built for web, so I'm going to be using CPU particles. it's just a difference in where they're processed. So here's our particle effect. Doesn't it look great? Okay, hold on a minute. So you just add a mesh to it, add a material to the mesh, and boom, there you have it, a particle effect. Easy. Okay, we need to do a little bit more. So if we just, here is a star texture that I mean, it still looks shit. What's going on? Essentially, you just need to turn on transparency, and because it's a particle system, you want to turn on this specific little setting here called vertex color, use as albedo. And what that will do is allow you to control the colors of the particles in your particle system, which I'll show you now. I'm going to turn shading off as well, so it's a little bit brighter, not affected by the lights. That's our mesh. It looks great. Let's turn gravity off. We want our particles to just float in the air. There it is. And last but not least, an emission shape. And boom, look, they're popping up everywhere. Isn't it great? So you can add a color ramp, and with this you can fade things in and out. Doesn't it look pretty? Are they blinking in and out in such a pleasing way? Particles, they're easy. Don't be scared. Right, let's move that to one side, because that's done, that's finished. I told you, this is going to be easy, fast, good for a game jam. So let's create a mesh instance 3D. So we've got our sparkle, and like you can create all sorts of effects with those particle systems, by the way. Here's some lightning, here's some fire. Also, fire, like, you can make all sorts, like, reuse stuff as much as you can, because you've not got time. I've got 7 minutes left. I need to be back here. So, mesh instance 3D. What I want to do now is make like an explosion, a burst of smoke. For an explosion, we want it to be a sphere. Make it 10 times as big. Boom, done. Ish. So we're going to do the same thing again, which is adding a standard material, new standard material, and this time for the texture, we're going to do all the same things. Alpha, shading off, vertex color on, and then in the texture, this time we're going to add some noise. Go into the settings, add some noise. Really good. So this is a noise generator built into Godot, really good for getting random values fast. It comes with lots of like knobs that you can tweak. You can change it up any which way. There's all sorts of different values. And what I want to do is add a color ramp so that we can again fade stuff out. Is that quite right? No, because transparency is disabled. This time, because I want like a burst of cloud, I want like hard edges. So instead of using alpha, which just fades things out gradually, I use alpha scissor. And what that does is gives a specific cutoff that lets you like fill in or fade out basically by size rather than by value. And so with this we can have like clouds that dissipate. And let's also just change this one right here. Gosh. And there we have, so now from here, we can have a dissipating cloud. And with that, we can copy this mesh. Copy. We can put it in our sparkle particle, and here. Copy. Paste. Boom, 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 boom. And so now you can see they're like all fading out. So real quick, real nice effect. And when you put them together, like make 5 of these slightly different, you can like do some really cool stuff. For example, oh, there's sound. Okay, but that's like, this is just that 3 times. 1, 2 on a slightly different shape. 3. It's great stuff. We're doing well for time. So we've seen some particle effects. We've seen some explosion effects. Last but not least, we want this sort of thing. So like fun glows. And this is a really simple effect to make. We'll start in the same place that we started before with a mesh. Let's move over here, get out the explosions. Cylinder. So these are all like sensibly like UV mapped. The top and the bottom is one half of the texture, and the other surface, the round bit of the cylinder.
Is
The what?
the tubey bit.
The tubey bit. That's the other half. So we can make a nice little cone shape. We can turn off the cap and the bottom, and we need to add our material and add basically turn off culling so that you can see the inside. So we're going to do a very similar thing again. We're going to add vertex color, turn off shading, and then in our albedo, again, we're going to put a noise texture. Again, we're going to put a noise texture. So we've got this far, but it's not looking quite as interesting as the other stuff we've got going on over there. What gives? Basically, now we need to make a shader, and this is the best button in Godot, in my opinion. Here it is, convert to shader material. So with this button, you can monkey around with these settings all you like. You can turn on distance fade, proximity fade, and it will turn it into very nice, human readable code for you to just tinker with. It's really cool. So it's got a bunch of stuff that we don't need, like the roughness and metallic. That could go. So you're going. Live coding. It's not so bad. I don't get what the big deal is. Cool. So we've got this texture albedo. This is the noise texture that we've taken in. We want to take that and also put a gradient texture in. So if we just copy the line, put a gradient texture, and we can copy this as well. Nope, gradient text. Autocomplete. So we can add, we've got a new parameter here, and we can just add a gradient texture right into here. And so we want it to look a little bit like this. We want this to be white, this to be transparent, and we want to multiply this one here. Boom! There it is. I mean, that almost looks right. Almost. There's just a few things that we need to change. It's not moving. That sucks. But it's really easy. It's a really easy thing to implement. So what we want is for the gradient texture to stay exactly where it is, but the noise to move around. So this is where the noise is being sampled. We can add time to that. Boom! We've got a flashy little effect. We've just written a shader. It's great. And so with this mesh instance, we can change its color. We can we can change its color. We can mess around with it however we want, and we can also take this mesh and again copy it and put it into our particle system. This is going to look weird. Yeah, there it is. And you can make by stacking effects on top of each other, you can make all sorts of cool stuff. For instance, these various little flamey effects, we can stack them on top of each other to make, where is it? A portal to hell! Yay! So that is, you've got the flame effect around the outside, the moving lava is the very same shader, and then we've got some like bubble particles also popping up, and this laser effect is again the very same thing. Single shader, just very simply, just chopping and changing the textures ever so slightly. There you go, easy. You can do it too. The key takeaways: make sure your particle materials are set up to be particles, so that's in the material settings. Just make sure that the vertex to albedo is set, and make sure that alpha is turned on because it's not by default. You can make complex stuff by just taking those simple effects and just stacking them together loads of times, and by doing it like that, it's really fast, so great for game jams. Use the convert to shader material button to see how the default stuff works. It's a great way to learn how to do shaders. For example, this one over here, this edge detection thing just uses, show me it in the inspector please. There we go. This uses a bit of code down here, but so as you can see here, proximity fade enabled. That's just from the default materials proximity fade property. So use the convert to shader material. Don't be afraid to experiment and add particle effects to everything. That's how you make it flashy. Thank you. Any questions? Any questions at all?
Did you make a game purely just to, that game jam game purely to make Final Fantasy effects?
Basically, yeah. Yeah, I really enjoyed it. If you want to play it, it's on my itch. It's called, you saw the title, it's called Summoner's Torment. It's a tribute to Final Fantasy, but it's also a vehicle for really annoying mini games. So
the truest of Final Fantasy games.
So like Final Fantasy.
Yeah. You have to do all the rituals to summon the creature, but you also have to keep your party healed at the same time. It's that kind of game. It's great. Any other questions? Then thank you very much. Nice and quick.